I embrace that quality of Zcash of maximalizing my anonymity set and keeping my money over the long term inside of a system with as many other participants as possible for privacy reasons. Just being the nexus of that for the whole world is sort of my vision.
This episode is brought to you by Chaos Labs, one of the leading on-chain risk management firms. You'll be hearing more from them later in the show. This episode is brought to you by Renaud Partners, the premier go-to-market advisory firm for early-stage crypto teams. Thanks to them for making this episode possible. This episode is brought to you by Ledger, the most secure hardware wallet trusted by 7 million users and securing 20% of the world's digital assets. We'll be hearing more from them later in the show. Hey Lightspeed listeners, we need your help. Lightspeed is conducting an audience survey to help us get a better picture of who our listeners are and what you want to see from the show. Think of this as our annual review. What do you like about the show? What could we improve on? If you want to contribute, visit the link in our show notes to fill out the survey and help us make a better show for you. Hello and welcome back to another episode of Lightspeed. I'm your host, Jack Kubanek, alongside Mert Mumtaz, and today we have an absolute stacked group of guests. We've got Zooko Wilcox, the founder and former CEO of Electric Coin Co., the company behind Zcash, who's now contributing to Zcash as part of Shielded Labs. We also have Sean Bowe, a former Zcash engineer who left the ECC in October, but is still working in an independent capacity and was very important in the development of zero-knowledge proofs. We have Anatoly Yakovenko, the co-founder of Solana. Zooko, Sean, Anatoly, thank you all for being here. It is
thanks for having us.
Huge episode.
It's a pleasure.
Yeah, thanks for having me.
There's a lot we can and will get into today, but I think just to set the table a little bit, I want to start with you, Zooko. So maybe just for guests who are less familiar, explain to us what Zcash is, what it does, and its function in the world today.
Okay, that's easy. Zcash is just like Bitcoin, except all the transactions are encrypted. And so what it does is that people use it to hold their money in their smartphones and then send it to each other in an encrypted way, which means that there's nobody anywhere who can see what they're doing. Is that sufficient? Does that make sense?
Yeah.
And what's the last question? What role does it play in the world?
How does so you said it's basically Bitcoin, but encrypted transactions. How does that actually work? I'm guessing everything is the same, consensus, proof of work, whatnot. But How does the encryption happen? How do we know, assume I'm some paranoid dude, how do I know how secure this is and how private it actually is?
Right. Yeah, that's a great question because that's where the zero knowledge proofs come in. Because when we started Zcash about 10 years ago now, end-to-end encryption had gotten pretty well figured out and well understood. And even when Bitcoin was new, Satoshi talked about whether we could use end-to-end encryption for protecting the users. And the reason we couldn't is that all the miners need to see the transactions so that they can reject invalid ones, right? And so with the invention of zero knowledge proofs that were sufficiently efficient to fit into normal end user devices, then we can replace all the miners need to inspect all the transactions part of the process with all the miners test zero knowledge proof. So now we can have the transactions encrypted just for the sender and the receiver and no one else. So that means the miners can't see anything. They just see ciphertext. But each ciphertext comes with a zero knowledge proof that the contents are valid. They don't double spend coins and they don't counterfeit coins out of thin air. And the sender of the coins had the real spending key that controlled those coins and everything. Is that sufficient? I mean, it's pretty simple. So we had to develop zero knowledge proofs to become practical and secure and scalable in order to do that. But the architecture is nice and simple.
Yeah, so that's Zcash, and zero knowledge proofs are a big part of how these peer-to-peer payments can be completely anonymous. And Sean, you were pretty instrumental in developing zero knowledge proofs, and also I believe in a blog post a couple months ago, you said you're now kind of independently researching how those payments can scale. So maybe you could explain a little more just how ZK plays a role in all of this, and then what's the bottleneck or difficulty of getting that to actually scale?
Yeah, zero knowledge proofs are sort of the magic trick that allow us to demonstrate that the transaction that's encrypted is valid, so we can peer into the encrypted contents. And that wasn't really practical until around the time, about 2013 or 2014, it became barely practical. And so that's when I teamed up with Zooko and some other people to develop the first actual deployed instance of this technology. And then we spent several years after that doing things to make it more practical for end users to actually use the technology. For example, initially our transactions were extremely expensive to create. They would take, they weren't even possible to create on a phone, for example. And on a computer, they would take maybe 30 seconds if you had a really good computer, or a minute or something for just a simple transaction. And so we spent years addressing these little problems piecemeal until we were able to get a protocol that was pretty fast for creating transactions and had really small transactions, but we still have the problem that as protocols scale, as there's more users on our system, you still have to pay to verify these proofs. So there's always going to be a bottleneck somewhere. And one of the goals for the Electric Coin Company many years ago was to start doing research on how to scale these zero knowledge proofs in certain ways, in particular to explore this concept called proof carrying data, which is where, or recursive proofs as they're well known, where we have proofs that sort of aggregate other proofs together into single proofs that can be checked, that sort of inductively demonstrate the correctness of basically, in practice, an indefinite number of other proofs, other transactions. And so this can significantly increase the scalability of a protocol, of a shielded payment protocol like the one we use in Zcash. There are other bottlenecks too, and those are the ones that we also spend a lot of time doing research and contributing to those concerns as well over the years. The great cryptographers and engineers that got to work with at the Electric Coin Company, including Dara Hopwood and Jack Grigg. And some of the major contributions we made on the proof carrying data front were this development that we called Halo, which was this new technique for doing recursive proofs that used kind of this little trick to make things a lot quicker and to expand the possible cryptographic primitives that could be used so that we could avoid things like trusted setups, and we could make different trade-offs in the space of possible decisions that we could make for the architecture for the proofs and for the protocol itself. And the other contributions is things like coming up with new user interfaces and user experiences for how payments should work in order to bypass some technical and cryptographic limitations that we still don't know how to solve. In particular, the main problem that seems to be more or less addressed is that when you send a payment to somebody, you don't want to send the payment to everybody and have everybody check to see if it's the payment to them or not. It's not really practical, and that's one of the several kind of absurd bottlenecks that we have to remove. But of course, we have to do so in a way that ensures it's private for users, and by making some adjustments to the way that the payment protocol works, we have ways to address that. So with this scalability initiative at ECC, it's a serious concern. As far as I know, at ECC, I left ECC because I felt like I would be able to contribute to scalability research for Zcash independently just as well as I could at ECC, and I would have a lot of freedom to explore some of the longer-term goals of the project and some of the kind of pie in the sky stuff.
It's interesting. The problem that you mentioned of, I believe the way it works is you decrypt, or at least attempt to decrypt, every single message. And that's one of the bottlenecks that you mentioned. And I think, Zooko, when we were talking, and I won't mention where, but when we were talking, I mentioned that I had a similar idea for Solana, and Toly said to use RSA accumulators to see if something is part of a group first. And so perhaps that can actually be a good segue into Toly here, which is, Toly, first, what do you think about Zcash? What was your history with it? Are you a fan? And don't hold back if you're not, but I'm sure you are probably. And two, what is, you're known as the scaling guy, let's say. What do you think about Zcash's scaling today? How would you think about improving it if you're on like an L7 engineers meeting right now?
Zcash is awesome. Like I'm a huge fan. I think it was one of the first. Like it's kind of like there with Tendermint. Like it was one of the first projects that I read kind of back and forth, and I grokked the initial kind of Merkle tree structure and all the stuff that you guys did to hide ownership of accounts, which I thought was the really, really tricky, hard part. And then my like scaling brain was like, oh man, this is going to be really, really hard to solve. I don't even know how to begin. So when we had folks that wanted privacy as a check mark in launching a token, like a stablecoin specifically. And we went through a bunch of exercises of what kind of privacy can we build for them. And the thing that we ended up in was using bulletproofs to encrypt the values of the amounts transferred between normal pseudonymous accounts. And that was a solution that hit the check mark for that like enterprise partner. Even though we build all of this, they still don't use it. This has been like my struggle with privacy, is that so far the people that say they want it are not the ones that want to use it commercially at scale. And I think once we find that user and that use case, everything else will kind of become obvious and fall into place, where to optimize and things like that. I think more fundamentally, I think privacy is important for the West and Western democracies, because it's one of those foundational things that keep us all free and together, and like the basis of like the social contract that we have between each other and the state is based on privacy and stuff like that. So I think it's super critical for us to have public decentralized ledgers that can guarantee a user's privacy when they need it. Otherwise, we may slowly out of level 6 PMs looking for promotions incrementally get to an Orwellian state where everyone's transactions are fully known and completely tracked and identified and de-anonymized. And maybe that state can be a utopia, but very likely it'll end up in dystopia.
Can I jump in?
Yeah.
Yeah, thanks for saying that, Toly. That reminds me of whoever, I think Jack asked at the beginning of this, something like, what role does Zcash play? And I didn't answer that directly, but now that you say that, I'm really happy about the fact that Zcash exists and people know about it, and it provides this like full strength, 2 to the 128 or 2 to the 256 or whatever kind of privacy that's just like sort of non-negotiable from the perspective of the level 6 PM or whoever. It's just fully under the control of the end user who has that app. And since everyone knows that, I feel like it's really helped. I think it really helps. I don't know. It changes the discussion. Like instead of the discussion being, should we allow this thing to be created? That's not the topic, right? Because everyone already knows that Zcash is already there. Yeah, I feel really good about that.
Thanks for the context. The thing I'm most interested in for this episode, and I'm sure we'll have different topics, but it's private money exists in the form of Zcash. Now, there are some other forms of it, which I'd be curious to get your thoughts on and the landscape of privacy and crypto overall. But first, I'm interested in Sean and Toly talking about, first of all, what are the actual performance characteristics of Zcash today? Like, how many TPS is it? Is it exactly identical to Bitcoin? And then Toly and Sean, how are you going to scale this to more people? How does this actually become more accessible? Or what are the challenges when you think about private L1s, let's say? What are the challenges for actually, what are the bottlenecks to solving those? And my goal with this is, of course, when there's engineers that are Rust engineers, let's say, who want to work on something like privacy, but don't even know what the bottlenecks are and need to do all this, preloading of information, what should they think about?
Well, there's a lot that goes into that question. So it's difficult to answer the question like how many TPS does Zcash currently support, because there's different kinds of shielded protocols inside of Zcash currently, and we're sort of bouncing around trying to improve things and deprecate old things. I would say it's within orders of magnitude of Bitcoin. There's nothing really substantially different in terms of its ability to scale compared to Bitcoin currently.
Can I jump in?
Yeah.
So we had a specific kind of way to look at scalability. So with bulletproofs and hiding the value transfer between accounts, even if that particular amount of that transaction, those cryptographic operations are expensive relative to a simple transfer where you're just moving literally numbers from one register to another, they're parallelizable. They don't touch any common state. So you can, if privacy is important, we will add the cores to make sure that we scale to all of the world's demand. Like the hardware becomes irrelevant once the system is parallelizable. Like this is kind of the main unlock that you need to get in a scalable system in the way that hardware works today, is because we can't turn up the frequency of a single chip. You're bottlenecked by whatever that single common piece of state is. And creating an anonymous account set was not something what we saw was possible. I don't know if it is today in a truly trivial to horizontally scale approach. And like that was like the really, really hard part. And I don't know if that'll ever be possible.
So I guess the one common state concern that we have in Zcash is just this thing called the nullifier set, which determines whether or not you've already spent the money that you're spending in a transaction. And that as far as I'm aware, almost all the rest of the common state can be for most practical circumstances you can just assume that it's not being touched, it's just being accessed, and that's pretty simple. And that's the main bottleneck that we focus on when we talk about the existing and future scalability concerns that we haven't really completely addressed.
So if we throw a bunch of GPUs at it, how many common nullifier setups can we do per second?
Well, no, it's not really like computing the nullifier. It's so the nullifier is essentially a hash, or you could call it a fingerprint that determines or that represents the spend of a node that you aren't aware of, and it gets added to a list, and then you cannot create a new transaction that has that nullifier in it again in the future once the previous one's been finalized. So it's just a matter of doing
atomic test and set. Sorry,
Yeah, exactly.
I'm interrupting. I want to say something about Toly's point that what that means is, so with that architecture, which you call horizontal scalability or whatever, you see, you already explored how that can be applied to where each SARD or whatever the right word is responsible for one account. And so as long as a single transaction isn't spanning conflicting set of accounts, you can do that in parallel. And so the way to think about the Zcash scalability is the same, but it's a nullifier subset that you can allocate to each different independent computer, right? Does that make sense? And that's totally doable. And then, well, I don't know. That's a hard engineering problem, but and the nullifiers don't have to. How do I put this? The only need for a nullifier is to prevent double spend. So it doesn't have to have any linkage or any necessary communication or relationship to any other data, basically, besides the coin that it is proving you haven't spent. Does that make sense?
Chaos Labs, the leading on-chain risk management firm, recently launched its new flagship Oracle product, Edge, which delivers integrated, high-precision risk and price data for any on-chain application with a market. Edge emerged from stealth after 2 months, securing Jupiter, the top swap platform on Solana, already securing $30 billion in volume and more than 60% of all Solana perps volume. Edge is comprised of 3 components: price, risk, and proofs. It delivers high-precision price data with an integrated risk engine powered by Chaos's advanced outlier and anomaly detection algorithm. It automates delivery of real-time parameter adjustments on-chain based on current market conditions, and it enables the secure on-chain delivery of custom data points, including reserve attestations delivered via ZKPs. Most recently, Wintermute announced its selection of the Edge Proofs Oracle for Outcome Market, its new smart contract-based election prediction market tool. Thank you to Chaos Labs for making this episode possible. Everybody knows there's a massive shortage of top senior marketers in crypto, and teams are constantly struggling to get their go-to-market done right. Renaud Partners is the premier go-to-market advisory firm for early-stage crypto teams. They help top founders tell their stories better and build great non-technical teams. They advise founders on all things marketing, tight brand positioning, community building, social media, and building A+ internal teams. They work with some of the top projects across Solana, Monad, Ton, Base, and others. Renaud Partners has built the most elite network of native crypto marketers globally. They create custom expert teams to support founders with transformative strategy work. Some of the best founders, VC firms, and ecosystem leaders in the business trust Renaud Partners to help their teams expedite their marketing success and catalyze their growth. If you're a founder or a VC looking for support for your teams, I highly recommend connecting with them. You can learn more at renaudpartners.com. Celebrating 10 years of innovation, Ledger remains the most secure hardware wallet for your Solana and logins, trusted by 7 million users and securing 20% of the world's digital assets. In recent years, Ledger has built a robust ecosystem of products and services, making digital ownership more secure and accessible to everyone. Ledger's newest devices, Ledger Stacks and Ledger Flex, feature the world's first secure touchscreens, making it easier and safer to manage your Solana transactions and coins. With Ledger Live, you can seamlessly and securely manage and stake your SOL. Alongside Ledger Stacks and Ledger Flex, Ledger introduced the Ledger Security Key app, a safer alternative to traditional passwords, enhancing your overall digital security. Thank you to Ledger for making today's episode possible. Zooko, one thing I want to ask you about as well that interests me about Zcash is just the question of its similarity to Bitcoin, which was also, originally conceptualized as a peer-to-peer digital payment network. It's now kind of seen as like digital gold. It's not really money. So does Bitcoin's failure to become money in most cases make you pessimistic about Zcash's ability? And I'm curious if you've ever considered something like a stable coin, because one of the real critiques of Bitcoin as money is, well, why would I want money that can like nuke 20% in a day due to market conditions? So I don't know, just walk me through kind of the moneyness of Zcash and what your
questions.
case is for that. Yeah.
Good questions, but I hope Anatoly will come back at some point and think about sharding of nullifiers. Maybe a little known fact is that Bitcoin was totally succeeding as for its use cases. Like Argentinian kids were using Bitcoin to buy Steam games off of Microsoft.com. And all the numbers were doing the exponential takeoff slope. Well, the darkening market was, as everyone knows, because it's a fun, exciting story. But so were normal above board above ground payments were taking off in the same way, until Bitcoin failed to scale. And then it hit this ceiling and bounced off. Then everything started going downhill in terms of usage rate. And a whole bunch of builders and entrepreneurs who had been counting on Bitcoin as part of their strategy were wrong-footed and went out of business and pivoted and so forth. So my number one answer is, let's have Zcash not do that. Let's scale Zcash before we exceed the current capacity. And then the other thing you said was about stablecoins. Oh yeah, and moneyness and like volatility of your money. I think that one's really interesting because I think for the first time, due to technology, the sender and the receiver are going to have like an abstraction boundary between them soon. And this is already happening even, but I think it'll soon have a large effect, which is where the receiver doesn't even know what asset the sender started with, or vice versa. You know what I'm saying? Like, I went to Chipotle yesterday, and I had some Zcash in my phone, which I have because it's awesome because no one can see it but me. So it's real freedom money. And I went and paid Chipotle for the burrito, and I presume they got dollars because I'm in the States. So they got dollars, aka Biden bucks. But I don't even know what they got. If they got euros, I wouldn't have known, right? And they have no idea what asset I started with, and that's a really different. That's really different because the concept of money as medium of exchange, unit of account, and store of value, the whole stickiness of it, which makes it have a network externality, which makes it such a big monopoly kind of deal, is because you've got to accept whatever kind of money your customer has to offer. And that might change because of like smartphones and blockchains. I think that's really interesting.
So I'm going to go back to where we were because I didn't get an answer. And I'm going to reframe it. So first of all, Sean, I believe I asked Zooko a while ago, like how many nodes are in the quorum for Zcash or how many, and then I believe the number is actually not known because like there's so many different weird layers of privacy that I don't understand personally. So Sean, can you walk me through fundamentally first principles, how Zcash works? You create a transaction, what happens to it? There's a concept of a shielded transaction, a regular transaction, and then there's kind of decrypting it. How does all that work as simple as possible without using, complex words for the Solana audience here? And then once we know that, Toly, I want your thoughts on the scalability without resorting to just throw more RAM at it. Okay, let's do that.
Sure. I guess let's see if I can get to the right level of abstraction. So, as a user, you're creating a transaction. So you have some information on your node that that knows how to spend some money. And as the network changes and as other people are sending and receiving transactions, you update the information that you have locally that with regards to your own coins that you can spend in order to, I don't want to use the word disguise, but in order to reduce it increases the so-called anonymity set of your coins when you actually go to spend them. So you create your transaction using that information. It creates a zero knowledge proof. The zero knowledge proof determines you've encrypted the information that I was referring to and any other details. And then the zero knowledge proof checks to see if the transaction is valid to the extent that it can. The transaction includes this thing that I referred to called a nullifier, which is like a fingerprint of the spend. And then some new coins are created there has to be some balance integrity of the transaction, but some new coins are created that are sent to different parties. And within the transaction, there are these blobs that contain an encrypted these ciphertexts that contain the information that the recipients will need to use to spend the money, part of it anyway. And that transaction is broadcast on the network. Now, in the way that the current system works, all of the nodes on the network, the validators, will check that the transaction is valid, that the zero knowledge proof is valid. They don't have to check everything that's inside the transaction has already been checked by the zero knowledge proof. And they check, crucially, that this thing called a nullifier hasn't been seen before in previous blocks, and then includes that in the next block. In addition, these transactions contain the new coin information, and that information is added to some sort of accumulator. In the case of Zcash, we just use a Merkle tree. And then everyone on the network currently will look at the blockchain and look at every single shielded transaction, ones of this form, and see if any of the new coins that were created contain a ciphertext that if I were to attempt to decrypt, or they were to attempt to decrypt, they get the information needed to spend whatever coins that are in there, and hence that they were the recipient of those coins. And then the process continues from there. So that is essentially the life cycle of a shielded transaction. And hopefully that gives you enough information to figure out what you were asking.
Right. Yes. So very simply put, on the bottleneck, everything is encrypted, and to know if the message is for you, you have to decrypt everything. Is that right, basically?
That's right, in the current incarnation, yeah.
Okay. Totally, what do you think?
I mean, the way it's designed right now is that was the kind of the hard part, is that you have a single Merkle tree structure, kind of like light protocol compressed trees that everything has to access as the state moves forward. So when you have like a million accesses, you have two issues. One is when I created my transaction, if it's referencing that state and somebody modifies that state, is my transaction invalidated? Now there's some tricks you can do to keep like a buffer or a memory of previous roots and stuff, and then do this like kind of do a bunch of tricks. But again, you're still bound by single thread physics, by single core kind of moving bits through that thing. And that part is really, really tough. And that coordination is hard. I think my vague understanding of what Sean described, the nullifier set approach, that sounds more complicated to implement, but potentially removes a bunch of the state contention. And if you can remove the state contention, you have scale. Like that is honestly it. Like there isn't anything more complicated than that. Because you literally do have twice as many cores every 2 years. It's like people hate it that it's that simple, but it is that simple. It's just for privacy, fundamentally, the challenge is that if I do a private transaction, it needs to be in a large anonymous set of people also doing private transactions. Otherwise, if you're the only one transacting privately, people just know it's you. It's that. So you need a large anonymous set, and you need that set to be non-contentious over a single state to scale it. So you're kind of in this fundamental hard bottleneck. So go ahead, Sean. You know the details more than me.
No,
I didn't butcher it.
No, that's fine. I think the thing that you mentioned, that it was, you called it like a buffer, sort of like a trick that can be used to reduce state contention on the accumulator for the commitments and the new coins that are created. I guess there's a couple things I wanted to mention, but if I can remember them, one of them is that there's a trade-off between the latency between when you receive some money and when you can actually spend it, and the anonymity set. But I don't think that that's a very significant trade-off, because like what you were just describing, where if you're the only one in the anonymity set, then you're not anonymous at all. But that isn't necessarily the case in our system, because we have, like if you use this buffer strategy that we were talking about, you go back like 100 blocks, use 100 block buffer or something or just take whatever you need, and spend from that old of a root in your accumulator, you still have a very large anonymity set. Of course, you're trading off the ability to spend the money that you receive for.
You can if you have receivers that like basically if you're a merchant, let's say you're just trying to hide how many sneakers you sold. You're not even worried about state level privacy. You're just somebody that's protecting their business secret, right? Which is like, I'm selling sneakers. I don't want my competitor to know how many I'm selling. For every sneaker that I receive through an anonymous payment, if I then go unshield it and then go deposit it into a bank because the bank doesn't support shielded payments, I've leaked that information to my competitors that just look at, this merchant is unshielding 100 times a day. They're selling 100 sneakers a day, right? So you need to have enough of a group of people that have a circular business where the customer is receiving shielded, payments for their work from their job, and that customer is spending at a merchant that's shielded, and the merchant is depositing back into a bank that's shielded. Then you have full privacy, and it doesn't matter if it's just one person per day transacting, because you don't know what that loop is or how often, how much stuff is happening there. It's the boundaries between the private set and the non one. If it's too small, you leak a lot of information through timing analysis.
There's something interesting about the time domain here. The way Zcash works, both in theory and in practice, seems really different in some really deep way with regard to what you're getting at, that like the time domain versus something else. So in practice, like I buy my coffee many times a week from a merchant who accepts Zcash for coffee. But that merchant currently in practice doesn't turn around and deposit it into their bank. Maybe they do once a month if they want to pay rent with it, or maybe they don't. I don't know, right? Because I actually don't. I've never asked. My point is, a very common paradigm about privacy is that it's sort of, I'm struggling to express this in like more accurate scientific terms, but it's like privacy per set of users per time, like now. But with Zcash and everything like it, like there's a lot of other things like Zcash now, but which Mert asked about earlier. That guy I buy coffee from is just holding on to it until some arbitrary future date. At the time when he then deposits it, like exits the shielded pool or interacts with the bank or whatever, his privacy set is determined by everyone who held on to it for the past like arbitrarily long time period. Does that make sense at all? It's like if you see a transaction, let me think of an example. If I send you a Zcash transaction, totally, you can look at it and you can say, okay, what can I tell from the information I personally received directly, plus whatever information the miners or the blockchain were forced to circulate? Okay. Starting with that information, what I can tell is this money came out of the shielded pool. And that means the source of this money or the prior owner of it or whatever, like stretches back for several years. Like anybody for the last several years could have been the source of this money, and there's zero information available to me to differentiate among those people. So anyway, it's a totally different paradigm compared to, well, here's another example. If people are using privacy of any kind as like a mixer, like a two-hop process. Like we start with our ETH, and then we're going to do something to it to make it more private, and then we're going to send our ETH to the final destination or whatever, or Sol. Sorry, but the point is, it doesn't matter what you do in the middle, because what you did in the first and the third step is already sufficient to de-anonymize your privacy, and that's very common. That people treat it like that, and so I don't know if this makes sense to you yet. Your face is too small on my phone to tell if you're nodding or squinting. So I think that's the biggest conceptual change that people are still not nearly anywhere near getting their head around, right? Like 99% of people are still assuming that privacy means sending your asset from one sort of visible position to a new visible position while somehow breaking the link in the middle. That's like the standard. That's like the concept of a mixer. That was the concept behind Tornado Cash, et cetera, et cetera, et cetera. And that concept is fundamentally broken. Like, it doesn't matter how good the mixer is in the middle. The act of sending it from point A to point C is already leaks enough information that the thing in the middle cannot help, no matter how good it is at not leaking additional information. And Zcash is different.
Right.
Well, no, Zcash could be the same. If someone, let me finish the analogy. If someone takes some Zcash, sends it into their wallet, and then sends it to Toly, and Toly can look at the blockchain and what he saw, and he can say, "Oh, somebody sent me the following amount of Zcash just now, and I can see that somebody withdrew that much Zcash from Coinbase yesterday," or whatever it is, right? So you can put two and two together. So if you use Zcash in that mixer paradigm, it also fails. Like every possible thing fails when you use it in that paradigm. But if you use it in the other paradigm, which is like your money, like privacy doesn't come from money in flight, it comes from money at rest. So if you have some Zcash sitting in your phone right now, and then you send it to Toly, he is totally in the dark. He has no way to differentiate between any of the people who've used it for the past several years.
So that was my point with having the merchant and the bank be in the same shielded pool, because then effectively the merchant's money can be at rest in the bank that is also shielded. So my killer app for Zcash would be a stable coin with yield. Go.
You've been tweeting about yield. You invented some kind of new economic stable coin today. I didn't understand.
Go convince a regular old bank, I don't know, maybe Texas or Wyoming, to issue a stable coin that is shielded and can get you yield. And that could start the privacy at rest and anonymous set.
Well, I don't get it, because people are currently holding Zec at rest. But maybe more of them would if we paid them to do so. And there was this stable thing happening, so-called stable coin.
Oh, actually, Zooko, you mentioned that you guys would transition from proof of work to a hybrid of proof of work and proof of stake, I believe. Do I remember that right? If so,
oh yeah,
how does that
that's my
work?
project. So that's my new project since I left ECC a little while ago. We've got, basically, I'm a security and safety maximalist, and I totally want to overdo it on security and safety. And at some point, I decided, so there's this totally practical reason why, since we have a whole bunch of Zcash infrastructure currently running, it's going to be easier to get them to take a baby step and add additional proof of stake into their proof of work instead of getting them to jump all at once to the new thing. So that's totally pragmatic user issue. But there's also this theoretical thing where I'm convinced that proof of work isn't really secure. And I'm also convinced that proof of stake isn't really secure. And we have a concept where you have to break both of them in order to rob any users. So that's what I'm in love with.
Why don't you think it's secure? Or Sean, do you agree with that? Like, what is your take?
I don't really think too much about consensus, those sorts of parts of the protocol, to be honest.
Okay, so why is it insecure? Or why do you think it's not as secure as it should be?
Which one?
Both of them. And then Toly will be like, I'll wait for Toly's answer after.
The problem is I can argue any side of this.
Yeah. I mean, you asked what's the deal? I mean, that's my sort of geeky answer. There's sort of a bigger picture, which is probably more important, which is it's like that stable coin. It's the yield bearing thing. People can get paid to hold Zec once we upgrade to the
Via staking.
hybrid proof. Yeah.
I see. Okay, so that's a good reason. But like, why is proof of work or proof of stake not so secure, or at least not as secure as you would like for private money at scale?
It's not secure because security means that the benefit to the attacker is less than the cost to the attacker, right? And everything we know so far, as far as I understand, which is less than totally and a lot of people, but as far as I understand, everything we know about this whole blockchain security stuff is about making the cost of the attacker high. But that doesn't answer the question. The question is the benefit higher or not as high as the cost to them? That's my answer. So we've never demonstrated that proof of work or proof of stake is secure, and they've at least proof of work has been exploited to defraud users and benefit criminals multiple times in practice so far. That's the other thing I look at is empirical evidence.
Okay. Actually, I'm kind of uninformed here, so I'm curious, Toli. What do you think about security in the context of those two, like when you contrast them? Or maybe another question that's related is like, why is Solana not proof of work? But maybe that's already included in the first one. So yeah.
The cost to come to agreement and proof of work relies on delay between blocks, because if you have two blocks created at the same time, you have a fork and you have to resolve that fork, and that's effectively noise. So I'm a Shannon-Hartley theorem maximalist, and you need to eliminate noise to increase bandwidth. So that is basically that's basically the problem with proof of work. The way I think about security is that if you had Oracle that guaranteed that every message is delivered to every subscriber, just then you don't need double spend protection. You've effectively solved the whole problem, because you don't have partitions, so everyone's aware of every fork, every double spend attempt, right? And then they can effectively reject double spending forks on their own. And then you can deterministically pick one or the other, right? Like at that point. So if you think about it that way, we live in a world where it's really, really hard to partition the global internet for an extended period of time. Maybe NATO can get away with it, but everybody would be aware of that partition pretty quickly. When AWS goes down, it's like 4 hours before it comes back up, right? When Meta has an outage, the human response time, like the detection is really quickly, is within minutes. And then the human person to go make it work again is about 4 hours. Go ahead.
Can I interrupt?
Yeah.
Well, first of all, the thing about Shannon-Hartley and delay reminds me of the thing about sharding. Like it's only because we have to coordinate information from both of those blocks that it's a problem, right? If each block was responsible for a different subset of the space of possible nullifiers, that would eliminate a lot of the noise.
If you can guarantee that the shards are not withholding data from each other, and you have some kind of like validity proof on the resulting computation from that shard, then you can have some assumptions that there's no double spend attack and somebody computed the right proof. But the sharding is you're literally creating two partitions, but what I'm talking about is within a single partition, single Bitcoin network. You have a 10-minute delay between blocks, because if you lower the difficulty and you have blocks that are occurring too often, you have forks. Even if everyone's aware of the fork, you still have to resolve it. So you drop one block and then go build on another one, right? So that effectively drops the bandwidth you allocated by 50%.
Right. Okay. So Zcash has those validity proofs because the zero knowledge proofs are the validity proofs, and then
so then you have to guarantee that I didn't withhold the data, and that everyone had a chance to compute. Everyone that wanted to had a chance to compute the validity proof, and had they computed a different proof, they would have the opportunity to propagate it and cause the network to deal with a double spend attack. Whatever that resolution is, I don't care, but like that's basically what you need to guarantee.
Yeah. Okay. Well, I think Zcash eases some of those challenges by transactions not being able to touch very much state at all.
That doesn't matter. It's literally attacker sends a bunch of Zcash to Coinbase and Binance, and if they can convince each one of a different validity proof, because they're preventing Binance and Coinbase from communicating, they've created a double spend and they've dumped their Zcash. Right?
I'm gonna cut this. That's enough nerd talk.
This is the fun part.
You guys can do that.
When Binance receives that Zcash, they need to have a guarantee that Coinbase saw the exact same route and
that's
accepted it.
Yeah. I interrupted you a minute ago because you were saying the internet's not partitionable, but then when it goes down, it comes back in 4 hours. Isn't people in China incapable of accessing Google for the last 10 years? And every time a country has an election, then everyone in that country loses access to the internet for like 5 days. I think the internet's a lot more malleable, partitionable today than
it takes a state actor that's cooperating with all the other state actors to do that. So like NATO can partition like the Solana, but you can't. And in fact, if you tried, there would be like an Obama drone strike heading your way.
But the people who live in Indonesia are subject, like their government could turn off Solana for them the way it turns off Meta for them every election.
Sure. But that is an expensive proposition. And that person could mitigate it if they are aware of their particular way that their state actor is partitioning them.
Maybe. Yeah. Okay, Mert wants us to stop with the nerd talk, but that was why I came was for the nerd talk.
All right. Okay. One thing I'm curious about is, so Sean, you're now doing independent work, but on Zcash, and probably what everybody who's listening wants to understand on some level is there are multiple privacy solutions, right? There's Zcash, there's Monero, there's Aztec, I believe, which is like the roll-up way of doing it. There are different types and form factors of privacy. So I'm going to ask you two questions. One is, what do you hope to accomplish with your work here? Like, what's the ideal state in like 3 years, 5 years? And then two is, how do you think about Zcash in the context of, let's say, the privacy stack? And like, how should other people think about it?
Yeah, so medium term, long term for Zcash. I guess medium term is to. I think that the scalability of private payments in Zcash is totally solvable with some trade-offs, and that is really encouraging to me. I think we've already figured out most of the solutions to most of the bottlenecks. So the main thing that I'm hoping to contribute to over the next few years is actually prototyping all of those solutions, the ones I've already talked about, and incorporating some of the new ideas that have come out in the last couple of years, whether they be just new cryptographic tricks or just incorporating whatever the state of the art zero knowledge proofs are, or proof carrying data, whatever else, into that model, and just seeing how performant it is. Just concretely, how many, what is the latency between when we send payments to recipients and they can spend the money, and what does the payment UX look like, and
make a shielded proof of stake network. Just like go mess around with Tendermint until you get staking to work in a shielded way.
Yeah,
that's what we're doing. That's not what Sean's doing, but that's what we're doing over at my organization.
Right. I'm hoping that a lot of these ideas are orthogonal enough that we can develop them at the same time. In terms of the privacy stack, I guess when you ask that, or if I'm getting your question right, you're sort of asking, where does Zcash's privacy, what is it offering to the world that, for privacy purposes, for people to take advantage of, that other platforms aren't, that other projects can't? And I guess this concept that we were talking about a little bit earlier about, keeping your shielded money, keeping your money at rest to keep it private. I think Zcash is a dumb money version of that I embrace that quality of Zcash of maximizing my anonymity set and keeping my money over the long term inside of a system with as many other participants as possible for privacy reasons. And just being the nexus of that for the whole world is sort of my vision, I guess you could say, over the long term, I guess.
Zooko, a lot of the blockchain world recently has been talking a lot about the idea of North Stars, and especially like Ethereum doesn't have a North Star, doesn't know what it's for. Solana is often brought up in that conversation because it's seen as like a decentralized NASDAQ. I don't think Zcash's goal is to like bring capital markets on chain, but when you talk about how many merchants can accept shielded transactions, how big that kind of economy can get, like, what is the North Star for Zcash? Is the idea that you want there to be a functioning economy today where I am using Zcash in my everyday transactions, or is it like a break glass in case of emergency thing where I hold my ZEC and then if I need to, if the US turns off my internet one day, I have it there so I'm not left cut off from the financial system?
Unstoppable private money. And that's actually not answering the question, because people use their money in their own ways. There's a bunch of people with cash in their mattresses out there somewhere, and there's a bunch of people doing cash transactions all day long at their business and everything in between.
Well, that is sadly all the time we have for today. It has been quite a galaxy-brained discussion. Really fun to kind of get to hear all y'all's perspectives and some of the back and forth here. Thank you so much for taking the time.
Thank you.
Thank you.
All right, everyone. We'll see you in the next one.